Howdy folks. So I thought today we'd start a new series on how to build a library with CMake. So we're going to start this project at GitHub and we're going to create a new repository. We're going to call it Introduction to Libraries with CMake. And let's add a .gitignore file. We'll use the CMake template. And let's add a license as well. We'll use the general public license. And let's create the repository. Now we need to clone our repository. So go ahead and copy the path. And CD into the desktop. And let's do a git clone. Okay, we don't need the command prompt anymore, and we don't need the browser either. So here's our folder, and inside we just have the Git repository, the .gitignore file, and the license. We'll also need a cmakelist.txt file. As always, we're going to start this project with the CMake minimum required command. I'm going to use version 3.0, and now let's give the project a name. I'm going to call this project foo, and now we're going to add a subdirectory. So the add subdirectory command just tells CMake to go into subdirectory foo and execute the cmakelist.txt file in that directory. So let's save this. And now let's create directory foo. Inside this subdirectory, we're going to need two additional subdirectories. The first is going to be the include subdirectory. And the second is going to be the src subdirectory. We'll also need a cmakelist.txt file. So let's open up the cmakelist.txt file. And the first thing we'll need to do is create the library with the add library command. The add library command takes two parameters. The first parameter is the name of the library. We'll use the project name variable for that. The second parameter to add library is the source code files required to compile the library. In this case, we're just going to leave it as an empty string. The add library command does allow you to specify whether you want to build a static library or a shared library. If you want to, you can put static right here, and then add library will build a static library. Or you could put shared, and add library will build a shared library. But we're not going to bother with this today. Instead, we're going to use the build shared libs variable. So when build shared libs is set to true, add library will build a shared library, and when it's set to false, add library will build a static library. The next thing we need to do is specify the include directories. For that, we're going to use the target include directories command. And we'll use the project name variable to specify the target. This is going to be public. The build directory and the install directory have different include directories, so we need to specify them separately. To do that, we're going to use a generator expression. A generator expression starts with a $sign and an open angle bracket, and it ends with a closing angle bracket. In between the angle brackets is going to be a key value pair. In this case, we're going to use build interface as our key. And CMake current source dir /include will be our value. CMake current source dir just means this directory. The way this generator expression works is when we're in the build directory, this entire string evaluates to this path. And when we're not in the build directory, it evaluates to nothing. Now we have to specify the include directory for the install directory. For that, we'll use install interface. And the path will be include. Because include is a relative path, CMake will add CMake install prefix to the beginning. So this will be the full path. Let's talk about this public parameter for a second. In CMake, we have something called build requirements and usage requirements. If we mark something as private, it's a build requirement. If we mark something as interface, it's a usage requirement. And if we mark something as public, it's both a build requirement and a usage requirement. Build requirements are anything that's required to compile a target, and usage requirements are anything that's required to link against our target. These include directories are required for compiling our target and linking against our target. Therefore, we mark it public. The next thing we're going to do is modify the name of our target. So right now our target's name is foo. But when we build a debug version of our library foo, we want the name to be foo-d. And if we build a static version of our library, we want the name to be foo-s-d. So that's what we're going to do now. Here we'll set the debug postfix to -d. The debug postfix will be added to our library whenever we build our library in debug mode. The release postfix will be added to the end of our library name in release mode. We're just going to set this to an empty string for now. There's also minimum size release, which we'll set to MR, and release with debug info. Which I'll set to RD. We also want to add -s to the postfix when we're building a static library. For that, we'll use the build shared libs variable. The set command will set static postfix to -s if build shared libs is false. So let's copy this, and we'll add this to the beginning of all of our strings. Now all we have to do is tell CMake about the include subdirectory and the src subdirectory. We do that with the add subdirectory command. Okay, so let's save this. And now let's go into the include subdirectory. We're going to need a CMake list.txt file. And there's going to be another subdirectory called foo. In this CMake file, we're going to start by creating 3 variables. One is the files variable, and we're just going to set this to an empty string. And then there's the subdirectories variable, and the relative path variable. Now we're going to use a loop to call add subdirectory on all our subdirectories. So here we loop through all of our subdirectories. On each iteration, we put the subdirectory in var, and then we call add subdirectory on var. Next, we'll check to see if there are any files in this directory. If the files variable has anything in it, this will evaluate to true, and the commands inside this if statement will execute. We're going to use the target sources command to add source files to our target foo. So here we're adding these source files to this target. We also want to install the files. To do that, we'll use the install command. This command installs our files in destination CMake install prefix / include. Let's save this. And we'll copy it. And we'll go into the foo subdirectory and paste it. Inside the foo subdirectory, we'll also need a hello.h file. Open the CMake list.txt file. And we're going to modify this to make sense for this directory. We need to add hello.h to our files variable. It needs to be an absolute path, so we use CMake current source dir / hello.h. This directory doesn't have any subdirectories, so we'll just leave this empty. And the relative path is include / foo. Everything else can stay the same, so let's save this. And we'll go into hello.h. In here, we're just going to create a single function called hello. And let's save that. Let's copy the CMake list.txt file. And we're going to go to the src directory. And we'll paste that CMake list.txt file into the directory. This directory is also going to have a subdirectory called foo. Now let's modify the CMake list.txt file to make sense for this directory. In this directory there are no files, so let's get rid of this. There is a subdirectory called foo, so let's add that. And the relative path is src. Let's save that. Copy. And in the foo directory we'll paste that. And here we're also going to need a hello.cpp file. Again, let's modify this for this directory. We're going to have to add the hello.cpp file to the files variable. And there are no subdirectories, so we can leave that empty. And the relative path is src/foo. So let's save that. And now let's create our hello.cpp file. Okay, now that that's done, let's go back to the foo directory. If you're familiar with DLL files, then you already know in order to use our hello function, we have to first export it with DLL export and import it with DLL import. This is usually done with an export macro. CMake can generate the export macro for us. To do that, we'll need to include generate export header. Including generate export header gives us the option to use the generate export header macro. The generate export header macro will create a file called fooexport.h. The full path for fooexport.h is CMake current binary dir /fooexport.h. Next, we'll need to install the export file. In destination include. Since our export file is generated in CMake current binary dir, we'll need to add this directory to our list of include directories. So let's add another generator expression. And we'll use build interface as our key. And CMake current binary dir as our value. This generator expression adds CMake current binary dir to our list of include directories for the build directory. Since we installed the export header in our include directory, and that's already listed here, we don't need any additional include directories for the install directory. At this point, I'd like to generate our project, so go ahead and save the file. Let's copy the path to our source code directory. And open the CMake GUI. And we'll paste that path in both the top and bottom fields. In the bottom field, we'll type /build. Okay, now let's configure our project. I'm going to use the code blocks mingw makefiles generator. Okay, I want to build a shared library. In order to do that, I need to set the build shared libs variable to true. If you look inside the CMake cache, you'll notice that there is no build shared libs variable. That's because the build shared libs variable is not a cache variable. In order to set the build shared libs variable to true, we'll have to add it manually. To do that, we'll use the add button. The data type should be Boolean, and it should be checked by default. Click OK. And now the build shared libs variable should show up in the GUI. Go ahead and click configure and generate. Now I want to go to the build directory to take a look at foo's export file. The export header defines a macro called foo export and sets it to DLL export anytime we try to build a DLL, and sets the foo export macro to DLL import whenever we try to link against our DLL. Foo exports will be defined by CMake, but foo static define needs to be defined in our build script. Let's go back to our hello.h file. We need to add the foo export macro to our hello function. And of course, we'll need to include the header file. Now let's go back to the foo directory. And we'll open up the CMake list.txt file. This if statement evaluates to true when we're building a static library. So we'll add our compile flags here. Now let's save the changes. Now I just want to tie up a few loose ends before I demonstrate that the library actually works. So let's go ahead and add an alias for our target. The alias target just allows us to refer to the foo library as foo::foo. Let's go ahead and save that. And now let's go back to the top level CMake list.txt file. Now I'd like to define the output directory for all of my targets. The CMake archive output directory variable sets the output directory for archive targets. The CMake library output directory variable sets the output directory for library targets. And the CMake runtime output directory variable sets the output directory for runtime targets. Next, I want to add the build shared libs variable to the CMake cache so we don't have to add it manually anymore. The options command will add the build shared libs variable to the CMake cache with a default value of true. This is just the doc string, which gives you a hint of what the variable is used for and will show up when you hover your mouse over the variable in the CMake GUI. Now I just want to demonstrate that the library does work by creating an example. So we're going to create a new subdirectory called examples. So let's save that. And we can close this. And let's create our new subdirectory. Inside this subdirectory, we're going to need a CMake list.txt file, as well as a main.cpp file. Let's start by adding our CMake code. In this directory, we're going to create an executable target with the add executable command. We're going to call it example. And the only source code file will be main.cpp. Next, we'll link our example executable against the foo library using the target link libraries command. So let's save this. And now we need to add the code to our main.cpp file. Okay, let's save that. And at this point, we should be able to build our project. So let's open up the CMake GUI. I'm going to delete the cache and rebuild the project from scratch. Make sure the build shared libraries is set to true. Configure the project and generate. Let's go to the build directory and open up our project. Now, if we did this right, we should be able to compile and run our example. So let's build this. And let's select our example target from the list. And let's run it. So as you can see, we do get hello world as we would expect. Okay, the only thing we have left to do is to push our code to our GitHub repository. So let's cd into our source code directory. And let's do a git status. I forgot one more thing. Let's go back to our source code directory. And inside the .gitignore file, I want to add the build folder to our .gitignore file. Okay, let's try that again. Again, let's cd into the source code directory. Let's do a git status. And let's stage all these files. And we'll commit the changes. And finally, we'll do a git push. Okay, everybody, that's it for today. In the next episode, we're going to talk about single configuration generators and multi-configuration generators. Thank you for watching, and I'll see you in the next one.